I'm from company OdinGG, and I'm here to tell you something a little bit about iterators and testing in Go. So far I know that it is good to say something about yourself or myself. So I'm learning Go since something like 2018, but it was just a hobby. And when I joined Odin something a little bit more than 2 years ago, since that time I'm Go backend developer. So I hope I know at least something. So first topic I would like to cover is iterators. As far as you know, iterators are pretty new to the Go. They are here since Go version 1.23. And I would like to tell you something about how they are used and how you can write them and what types we do have. Basically, as you can see, we have two styles of iterators. The basic style is so-called push style. It is the one that is natively used in the Go. It is tightly connected with some types, generic types. As you can see, they are called SAQ and SAQ2. And we can call them iterator themselves. So it's like, I will call them iterator and pair iterator. They are using some function yield, through which you publish all the values outside to the outside world. And outside world is consuming the iterators using simply for range loop. Nothing else is needed. I will show you an example in a while. And second style of iterators are so-called pull style iterators. Those iterators are somehow, let's say, they are important because of sometimes you don't need to use simply for the range. If you need them, you can simply use pull or pull2 variant of function from iter package, and you are good to go. I will show you an example of them a little bit later. So, iterators in standard package. Basically, as far as you know, iterators are already built in Go. So on the left side, you could see there are a lot of possible iterators already available. These are not exactly iterators, these are constructors of iterator. So if you would like to iterate through all the values in map, you could use maps values, give their map as argument, and you will get the iterator. What is important? Important is that I told you that there are some iterators as type. This iter SEQ, this generic type is iterator itself. What it is truly, it's just a function that gives you another function through which you control it. We can see it here on next slide. Here is how easy it is to use iterators. Here we have some example map M, which is pretty simple, which you can see. And we can see here two examples of usage of the iterator itself. The first one is just iterating over keys of the value of the map. And second one is iterating over both keys and values. So this example, it is how to use iterators. It's really that simple, nothing more you need. Of course, iterators can be also held in the variables. So if you write iterator yourself, you will write something like this. This is an example of iterator that is taking as input simple slice, and it is iterating over a slice and returning every second value. So for this example, the slice of 1 to 0, 1, 2, 3, 4, it will return just 1 and 3. If you will take a look on the code itself, you could see that we are constructing a function that will take some function from outside the world. This is the yield function. And every time when you call yield, you are publishing one value out. So this is how you can write yourself simple iterator. I hope it is hopefully that enough, sample enough for the first case. Iterators can be a little bit more complicated. This is iterator that is, it is inspired by enumerate function from the Python, which takes an enumerable and basically adds there the index. So you take an iterator that you already have, in this case, every second from the previous slide, and we can simply call on this iterator another one, enumerate, that will transform it into enumerated iterator that will return both the index and the value itself. Of course, it can be also a little bit more harder. We can put there some additional arguments to modify the behavior in this iterator. This example is really simple. It's doing just one thing. It's taking one extra argument. You can see here it's a value of 10, and it's the offset of returned index. It's really simple. You could try it yourself. And I encourage you, try it. It's really simple. And sometimes it can make your consuming of collections and other stuff pretty easy. I told you we have also second style of iterators, so-called pool iterators, and this is example. I stole it from the standard package. From the iter package, it's just an example from there. I just a little bit modified it so it fits here on the slide. And you could see we take some iterator, which is the original one, and there is called iter.pool. This iter.pool transforms the original iterator into the pool style. So it returns two functions, function next and function stop. As you can see, stop is simply deferred. As far as we stop, we don't want to have any resources leaking. So it's a good behavior to call it. And then we simply, every time we would like to get a value, we call next. It returns two values. One value, which might be the value taken from the iterator, and then flag that will give you information whether it was true or the iterator was already depleted. It makes sense. If you don't need to use for loop, this is the way how you can operate. And by the way, if you take a look in the iter package documentation, it's not written that easy to understand that this is the sole purpose of it. Okay, second topic, testing. Everybody tested, and who tells he didn't do it, he's doing every day. It's a little bit tricky because of there is like, let's say, no base point of knowledge about the testing. And you could see that everybody was writing some tests, but there are many possible styles. And it's not that easy to, let's say, think together with your teammates about how to use testing, how to write tests to make them readable, and so on. So I would like to give here just a few basic pinpoints that might be viable for teams that need to cooperate somehow and write unit tests and so on. Testing is a really big topic, and you know there might be a lot of tests. End-to-end testing, integration testing, unit testing, manual testing for any new stuff, because of every developer usually does manual testing. You could do performance testing with some extra load, smoke testing to be sure that you didn't broke anything by your modifications. Fuzzy or property-based testing is also a pretty big topic. You could try mutation testing, which basically means that you try to break the stuff by changing its code. This is more stuff over Python. In Go, it's not that easy, but you should know that something like this is also possible. I believe most of developers already also hit some flaky tests. This is something that you would like to not produce so often because they are usually breaking stuff and CI and everything. For those who didn't know this term, fluky test is the test that is behaving undeterministically. So it may fail randomly. And this is something that will most possibly happen on the place where you don't like it. And I would like to talk here about the basic stuff that will support unit testing and integration testing. All other stuff is, let's say, we don't have that much time to cover all the stuff. Maybe next time we can do some more specific part. What is important to, where to start when you write unit tests? It's good to know that there are two different approaches, basically. One is that you take standard building blocks and you don't want to pollute your project with some extra third-party dependencies. If you do so, it's okay, but usually you will write a lot of code that will support you somehow. But it's very natural. Anyway, if you do it other way, it's still good to know that there is the basic way. And you may hit some test that is written using this way. So let's say some building blocks from standard library. You got your T parameter, which is your interface for testing. And if you take a look in description of how many methods it has a lot of methods. So basically, you should know that there is some possibility to do skipping. And there is skip, skip now, skip F. Difference is pretty easy. Skip, you will give their message that will be printed. If you use skip now, it will skip and basically just write basic stuff, just this is skipped, nothing else. And skip F is just adding there some formatted stuff. Then, maybe you don't know it, but standard testing framework has something called testing short. And it is connected with you run go test with optional short. Then this testing short function will return you true. Otherwise, it will return you false. You could use it to divide your unit test into some quick ones and slow ones. And for example, you could run quick ones at first and slow ones later and this kind of stuff. It needs some effort, but it might make sense. Also, we got testing T, testing M for some main testing if you would like to write yourself some test suite, testing B for benchmarks, testing F for fuzzy testing. It's good to know that all this is also basic supported stuff from standard Golang. Okay, so we got standard testing. It's good to know that if you fail the test, we have also several ways how to do it. If we call fail, it will just simply mark the test as fail without anything else. But the test will continue run, so you can see message will be printed. If you call T error, you will fail it with some extra message. If you call fail now, it will stop exactly at this time. It will basically use panic or some different similar mechanics, and the next line won't be done. So good to know, if you call fail now, it doesn't continue. If you do any other, there is high possibility that it will continue, so it can produce some additional things. If you use custom package, very often there is used from stretcher testify. It has two different approaches or two sub-packages, assert and require. Assert is basically used if you would like to continue with the testing, and require is used if you need to quit as soon as possible. So it behaves the same like fail now from the basic testing standard package. What's good about this one? It's pretty nice, it's readable, it's using same interface, and it offers plenty of methods. If you start using it, be sure you take a look into documentation and check all the, 60 methods that are there, that you have at least basic overview about how you can test. Because of testing errors with errors it's much easier, and it will give you much more readable stuff. Okay. Okay. So know your tools. If you are using Testify, check the documentation. Be sure that there is something about testing for nil, not nil, no error, error, and so on. You can check error is, you can check for equality. If you check for equality, be sure that you give there always the same types. If you try to disequal, it will always fail. It's pretty sad because of it's just int and uint, and one might think it might be okay. No, it's not. If you would like to test something about pointers, use same. You could write yourself some helper functions. If you do so, you could try to write whatever you want. Just if you called anything, not to break how where the stack trace of the failed test, always called t-helper. This is the most important if you call anything from your tests, and you might put there any assertion. If you could write yourself a lot of assertion tests or assertion functions. If you do so, this is one example how you can do it. This is, for example, a similar test to the one from the Testify package. That is testing that the pointers are pointing to the same value, but on different addresses. Okay, we can run tests also in parallel. If you do so, you mark every test explicitly by t-parallel call. And what it does is basically, it will gather all the tests. Everywhere is t-parallel called will be somehow paused. All the tests that doesn't have t-parallel call inside will be run in the sequence. And all those that are paused are put in some queue, and they are tested later. And depending on the parallel level which you enter, that many tests can be run, or that many Go routines will be used to run through the tests. So use it. You will make your tests sometimes quicker, but be sure that flaky test will appear as soon as you might hit them. Also, you should know that there are some possibility to write subtests. Subtests are started by trun. You put there some, basically some title that will be added to the test name, and then the testing closure. Here, for example, you can see that there are 3 subtests run, and this is how it usually, how you can usually see it in standard output and, for example, in Golang. Similarly, you could use subtests in a little bit different manner by using table-based testing. It's pretty similar, but usually you create some data, use them like a table, and then run it with one for cycle. It's pretty similar, whatever you can use. It's good to include their title in each of the unit tests in this case. If you do not do so, you need to generate it somehow, but then your IDE will be a little bit crazy about it. If you include there really the test case, it will show you which tests really failed, and it's much easier to debug it. Okay, just really shortly, fuzzing or property-based testing. If you would like to test your something really hardly, you could use fuzzy generator, but usually it means that this is the test that if you will run it in CI, it will never end, most possibly. Or if it will end in something like 3-4 minutes for testing of single integer value. So basically it's working in the way that you put there some corpus, like the seed, and then it starts a generator for putting there some reasonable outputs for your function and testing if still all your assertions are working well or not. This is just an easy example. You could try it yourself. And by the way, it's not that easy, but you may put there some constraints. on the input. If you would like to include there some more integration testing, I got some experience with using test containers. They are pretty okay. Here you can see some example how you can prepare a test container for Redis. Basically, test containers are handling all the Docker behavior on the background. You don't need to test it. What I can tell you, it's easy. It can be tricky. Be careful about it. And you could simply take the endpoints for your tests. So during the test, if you, for example, debug it, you can still use your, I don't know, Beaver or anything to take a look into the database in the runtime before the Docker container is quit. So it's also possible to debug it somehow. And if you would like to get the information about how it is running on the background, enable logger, and the test container will log you information about, hey, I'm starting container is ready, downloading, and this kind of stuff. So if you are debugging it, enable debug logger, and you will see a lot of stuff going there. If you try to do something about mocking, on the left side, there is some easy way. A lot of developers know that we can embed structures, but we can also embed into structures interfaces. If you embed interface into your structure, it will behave like the interface, but it will fail on every function that is not explicitly declared or defined. If you would like to do mocking more, I think that using of the mocker is pretty good. You write simply configuration file, and then you can simply generate your mocks for all the files from some package and so on. Basically, if you need to mock, you need to write against the interface, and all the interfaces might be mocked. Then, of course, those mock are fully tasted, so you can test if it was called with this arguments, what it should return, and if it was called once or twice, and this kind of stuff. So mocking is okay. It's true in Python, it's much more tasteful, but for a Go, it's still good enough. Okay, basically, if you would like to take a look or yourself about some samples for the unit testing, you could go for this URL. And basically, this is all that I wanted to give you the basic information. And if you got any questions, feel free to ask.